Right. Yeah, beautiful. Friends, as we have come to another class with different mindset, I want you to know that you are the right place. So what we're going to do today is, as you can see over there, we have a simultaneous equation which says 2x plus 3y is equal to 8, and 3x minus y is equal to 23. Well, the discussion is boiled on. Our discussion is definitely based on Cramer's rule. Cramer's rule. The Cramer's rule, after teaching simultaneous equation in this level, this is actually more or less like a basic, yeah, basic or intermediate. Okay, intermediate level, intermediate, intermediate level. Okay, so we saw that Cramer's rule was very interesting because it takes seconds for one to be able to compute and solve the simultaneous equation within the shortest possible time. So the Cramer's rule, well, it's another method for solving simultaneous equations. Even though we have methods such as elimination method, substitution method, matrices, and etc. What I realized that most students preferred implementing the use of Cramer's rule to solve the simultaneous equation after taking them through all the methods. Well, so I did a survey, and my survey showed that most of the students prefer the use of Cramer's rule. Why? I don't know why, but to me, if you know what you're about, or if you understand the principle and method within which you've been taught concerning this elimination method, substitution method, and by matrices approach, in any way you must be able to solve the equation with ease without difficulty. In this class, I take it as an intermediate class because we are not going to do a 3-dimension or 3x3 matrices, but this is going to be 2x2 matrices to explain what we are going to do. So as you can see right on the board, our equation we have over here is what 2x. Okay, so that's the equation. 2x plus 3y is equals to 8. Okay, then our 3x minus y is equals to 23. So let's see the reason why every student is interested in using Cramer's rule. But before then, we will start with our elimination method, followed by substitution method. Then we'll look at it from mattress point of view. Then we come back to our final Cramer's rule, okay? And you will judge it by yourself after looking at what we've done, whether you think the Cramer's rule is the best one to solve simultaneous equation with ease. Wonderful, 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 wonderful. So let's see. Let's go there and have a page. Okay, now, beautiful. So if the question says 2x. Let me use a plain one so we can understand. So the question says, okay, it says 2x plus 3y is equals to 8 as our first equation, and the next one is 3x is minus, so this the next one is minus as we're given, as we are not reinventing the field. So 3x minus y is equals to 23. is equal to 23 as equation 2. Now, we are going to use elimination method. So let's see if this is, we're going to use elimination method, elimination method. So what do we do? If we look at the equation very well, you see that we have 2x plus 3y equals to 8 and 3x minus y equals to 23. So if that is the case, if I multiply the equation, let me say multiply, so multiply the equation 1 by 1 and multiply the equation 2 by 3, as you can see, you see that we have 2x and 3y. So when you multiply the 3 through the equation 2, our equation now becomes 9x minus 3y is equals to 69. So we're going to call this equation 3. Okay, so the first one, 2x plus 3y is equals to 8. Okay, so this is the matrix. So sorry, this is the equations. So now we're going to add this equation 1. So we say add equation 1 to equation 3. So by so doing, you see, when we add 2x and 9x, that's 2x and 9x, okay, and also we add plus 3 and minus 3, you'll see that the 3y minus 3y will be 0. So 3y will nullify itself, okay. So we're adding them now. So when we add the 2, we're going to get 11x to be equals to 77. Okay, then it implies our x is equal to 77 divided by 11, meaning x is equals to 7 as our first value for x. Okay, now isn't that beautiful? It's beautiful. So now we can substitute. We can put 7, x equal to 7, in any of the equations to solve for the value of y. So if I take the first equation, which is 3x minus y is equals to 23. Okay, so it's going to be 3 out multiplied by 7 minus y is equals to 23. Then this will be 21 minus y is equals to 23. So our minus y now is equals to 23 minus 21. Okay, isn't that beautiful? So minus y, this is equal to 23 minus 21, that is 2. So this implies that our y value is equals to negative 2. So look at it, is it not so simple and beautiful? So you realize that the values will go for x. Okay, the value for x, as we got it to be 7, and the value for y is negative 2. These are the answers for using the elimination method. Elimination method, as you can see, all what we did was we multiplied the first equation by 2 and the first equation by 1. first equation by 1, second equation by 3. And after that, we added it together, and our values for x is 11 over 7. That gives us 7. Okay, we put x equals to 7 into our first equation, which is second equation, which is equation 3x minus y equals to 23. Then finally, this is the answers we got. Okay, now let's see whether this is faster as compared to the next one we are going to work on. The next one is the substitution method. Okay, so the substitution method. Okay, so it's the same equation. So we say 2x, the same equation. Yeah, the same equation. So the same equation is 2x plus 3y is equals to 8 as earlier, as we saw earlier. So that is equation 1. And the next one is 3x minus y is equal to 23 as equation 2. Okay, so I say from equation 2, okay, I can say minus y is equal to 23 minus 3x, making y the subject. My equation will become 3x minus 23. Okay, so this is a substituent. Okay, this is we can decide to call this equation 3. Bear in mind that we derive this equation 3 from equation 2. So therefore, we cannot substitute this equation back to equation 2, as it will cancel itself. So what we do is we say substitute. Yeah, this is a substitution method. So we say substitute. Okay, equation 3 in 1. So we are going to substitute equation 3 in 1. Okay, so what I'm gonna do is I'm gonna write the equation as it is. So it is 2x, okay, plus 3 into bracket, okay, into bracket. All right, is equals to what? 8. I just want to substitute the equation 3 in different colors. So that will help us to understand what we're doing. So our equation 3 is what? It's 3x, okay, minus 23. Okay, so this is what we get. So we have to expand it. And when we do the expansion, this implies that 2x plus 9x minus 69 is equals to 8. Okay, so implies 11x is equals to 77. Dividing both sides by 11, our x is 77 over 7, which is equals to 11. Okay, so we've got our answer for that. So now I'm going to substitute the answer, our what's the name? The answer, yeah, 77 over 11, sorry. So that will give us 7, sorry, 7. I think I'm going to clean to present it very well so you guys will understand. Okay, so you know we are live. Okay, so this, let's clean this and that. Yeah. Okay, so we come back here again, and we know this divided by 11 will give us 7. So this implies that our value of x is equal to 7. Okay, so now let's substitute. x is equal to 7. Okay, in equation 3. In equation 3. So, our equation 3, we know that our equation 3 is y equals to 3x minus 23. Y is equals to that. So y, this means y is equals to 3 times 7. Okay, let's make the 7 in different colors so we understand what we're doing. So we'll put it here as 7. Okay. Then all into bracket minus 23. Okay, this gives us 21 minus 23. So this implies that our y is equals to -2. So we see comparatively, we realize that the answer we got for our what's the name? The method of substitution is the same as compared to the one we did for elimination. Yeah. So let have a look. You see, let's recap. You see, so with a substitution method, it was the same equation in play. So we said 2x plus 3y is equals to 8. Okay, that is what we have over here. This is the equation which we haven't changed, and it is the same equation. Okay, then we say from 2. You see, our target, our concentration was on 2. So what did we do? We made the y the subject, okay, stepwise. So y became negative y is equal to 23 minus 3x. Okay, then we came down here. Okay, we made this the subject. So we said this is equation 3. Then we substituted the equation 3 in equation 1. And our equation 1, we know is 2x plus 3 times y. Because the y, this y that we see over here, okay, is what we have over here. So we substituted this all the way to this equation. Okay, then we have 2x plus 3 into bracket 3x minus 23 is equal to 8. Then when we computed it, our final answer we had was 7. Bear in mind we're doing substitution. So we say let's substitute the answer that we have got, okay, into the equation 3. This. Okay, and the value was 7. So y into brackets 7 minus 23. So and we all know that when you multiply 3 by 7, you're gonna get 21 minus 23, as you can see. So 21 minus 23, that gives us -2. So as compared to the elimination method, let's see what answers we got. So this is the answers we got for the elimination method. You see, this is the elimination method, meaning we are on track. Now, I think we have to look at it from metrics point of view as well. So let's see with the metrics. Yeah, the same equation. We are not reinventing the wheel. So we say by metrics, okay, by metrics method, by metrics method. Okay, what is the equation? The equation says 2, right and white, so that we can see clearly. So the equation says 2x minus 3y is equals to 8 as usual as equation 1. Then our next one is the 3x, okay, minus, let's go back and refer to the equation. The first equation, see this is plus, okay, and this is minus y is equals to 23. Okay, so the first thing we have to do is to be able to put this one in the form of matrix. Bear in mind that we have x here and y here, and this is equal to the right hand side values. So to write this one in matrix, this will be this 2, 3, 3, -1, all into bracket multiplied by xy is equals to 823. That's my matrix form. Okay, matrix. Now, to be able to solve this equation using matrix, the first thing we have to think about is our determinant. Okay, determinant. Okay, so determinant of the matrix. Okay, so let's say if our matrix A, okay, so this we call it matrix A. Okay, then we look for the adjoint of A of the matrix. Okay, so our matrix is A multiplying xy is equals to what? 823. So this is a matrix A. Because A is the matrix 2, 3, 3, -1. Okay, so how do you find the determinant? Determinant of A. Determinant of A, DTA, is given as multiplying the diagonals of the matrix subtracted from the left diagonal. So let me say it again. We multiply, the left diagonal. This is the left diagonal. The left diagonal. Okay. Then we subtract from the right diagonal, multiplication of that. So what it will be what? Have you got it? Yeah? So we multiply the left diagonal and subtract from the right diagonal. So let me put it here. So left diagonal minus right diagonal. Okay? So now let's see. So determinant of that is going to be 2 multiplying -1 minus 3 multiply 3. Okay, so what do we get? -2 minus 9. So the determinant of the matrix A is now equals to what? -11. Okay, so this is the determinant. How I made mention of determinant, and I made mention of the adjoint. Okay, with the adjoint, small note, with the adjoint, we transpose the right diagonal and we negate the left diagonal to get our adjoint. Okay, so that the matrix, as we saw, is A. Matrix A is given as 2, 3, 3, -1. So the adjoint of this matrix A will be, as I said, we transpose the right diagonal. So the -1 will come up and the 2 will go down. Then we negate the right, so now we negate the negative, then the left diagonal. Okay, so we negate the left diagonal. So we negate this will be -3, -3. So that will be the adjoint. -3, -3. Okay, so how do you find our answer? The answer, as I wrote earlier, so that we know that the matrix, yeah, matrix A, let me clean it. Our answer, let me clean that one. A, our matrix A. So let's go up and I'll show you a little bit of a, yes, with this equation as we see over here. Okay, when we multiplied A inverse to the right one, so we're going to get A inverse. Okay, so now let me show you something. A inverse, if I say A inverse multiplied by A inverse over here, okay, we will get the A times A in matrix. When we say A times A is equals to identity matrix. A times A inverse is equals to identity matrix. So when we multiply that, you see that we're going to get our xy to be equals to 823 multiplied by our A inverse. Okay, so our xy, so since we have A times A inverse, xy is equals to A, this is 8, 3 multiplying A inverse. Okay, this one goes down to be identity matrix. So multiply identity mod I, multiply xy and 823 that with A inverse. Okay, this identity matrix multiplying xy will be xy into bracket equals to 823 times A inverse. And how do you get A inverse? The A inverse is given as one of the determinant of A multiplied by the adjoint. Okay, so this is equals to the determinant we got was negative 11. So this will be 1 over 11 minus 1 over 11 multiplying by the adjoint, which we had it to be, as we go up, this is our adjoint. The adjoint, which is this. So we multiply back, we put it back into the equation. So this multiplying, okay, the adjoint, which is negative 1, negative 3, and negative 3, and it's 2 multiplying. Okay, so that will give it the adjoint. And when we finish, we'll put the A inverse, which is now this, is the value we're going to get from for this. Okay, so then we'll multiply 8 by 823 will give us our values for x and y. Okay, so when we compute, you see, we're going to get s and y to be equals to negative 1 over 11 by negative 8, negative 59, negative 24, plus 46. So what happened is we take negative 1 and multiply by 823, and after that we do the same with negative 3 and 2 and multiply by this, and this is what we get. Okay, see that matrix method is so easy. So you know, xy will further because the minus 1 over 11 times this minus 8 minus 69 will give us negative 77, and here will give us 22. Okay, since we're looking for the values of x and y. Okay, So our x value, yeah, if you compare the x value and the y value, x will be equals to negative 1 over 11 times negative 77, and that will give us 7. And the y is equals to negative 1 over 11 multiplying 22. That will give us negative 2. Fantastic. So you see, here again, the values of x and y are the same as we got with the two methods, which is the elimination method, substitution method, and now we are getting the same for our mattress method. So let me go back and recap with the mattress method, which some people may think is long, but it's so easy. So with this mattress method, okay, this is the mattress method. Okay, there's the same equation. So all what we did was being able to put this equation in the form of matrix. So you see, this is 2, 3, 3, negative 1. If we multiply x and y to this, we get back to where we were, and that is equal to 8 over 3. So the matrix, this is a matrix equation as we've written over here. And we select 2, 3, 3, negative 1 to be the matrix A. So our first step, solving matrix equation, simultaneous equation, we got to find the determinants of the matrix A and also find the adjoint. So determinant, okay, of the matrix A and adjoint will help us to be able to calculate the inverse of the matrix. Okay, so then I said here, since we have this equation, A multiply xy, then it's equal to 8 to the 3. We'll multiply A inverse to both sides of this equation, particular equation. Then, okay, then we know our A is that. Okay, now let's see. A has been given, so we have to find the determinant of this matrix. How do you find the determinant of the matrix? As I rightly said, you multiply the left diagonal, okay, and subtract from the multiplication of the right diagonal. So the left diagonal is 2 multiplied negative 1, subtracted from the right diagonal. So we say 2 times 1 is negative 2, and consequently we landed to negative 11. That is our determinant. Okay, then the adjoint, as I said earlier, the adjoint, we transpose the right diagonal and we negate the left diagonal. Okay, so that's what we did. The matrix itself, the matrix A, was given as 2, 3, 3, negative 1. So when we did the adjoint, we transpose negative 1 and 2. So negative 1 came up and 2 came down. Then we negate the 3's, okay, on the right diagonal. You see? So this is the adjoint. And when we multiply the adjoint and the determinant, gives us the inverse of the matrix. So as I said, when we multiply A of being a matrix by its inverse, it is always equal to the identity matrix. And the identity matrix is always symbolized by I. So that's the reason why I put I here. So I x y is equals to 8 times 23 times the matrix inverse. Okay, so the identity matrix multiplied by xy, okay, will give me xy. Why is it so? Because identity matrix I is 1, 0, 0, 1 matrix. 1, 0, 0, 1. So when I multiply this by xy, yeah, I'll get back to the same xy over here. So as you see, the A inverse is one of the determinants multiplied by adjoint. So we substituted everything respectively back to the equation, we have our xy to be equal to -1/11, which is the determinant, multiplying by the adjoint and the values that budges out of the equation. So 823, yeah, that's it. So after computing, that is what we had. We have our x to be equal to 7, y is equal to -2, as we saw earlier. Now, let's see whether students are right if they prefer using Cramer's law instead of all this method we've talked about so far. Okay, what is Cramer's law? So Cramer's law. So Cramer's rule or law. Okay, let's see. The Cramer's rule is nothing other than, calculating, putting and calculating everything in the form of identity. Yeah, like the determinant. So identity of Cramer's law is all about calculating values of the determinant of the equation. So the ratio of the two give us the values of x and y. So let's look at it again. So with the Cramer's rule, we have our equation once again to be 2, 3. So our equation is 2, 3, which is 2. Good. Our equation is 2x plus 3y is equals to 8 as usual. We are not reinventing the field, the same equation. And the next one is the 3x minus y is equals to 23 as equation 2 again. So this, the Cramer's rule, we'll still have to be able to write the equation in the form of matrix. Then with that, we'll be able to solve for the values of x and y. So let's see the reason why students prefer that one instead of all the methods mentioned earlier. Okay, so this will be 2, 3, 3, -1 to bracket xy is equals to 8, 23 again. Okay, so now we're going to look at it. That if we say this one is a, this equation is a, then our determinant, as we saw earlier, we multiplied the left diagonal and subtract from the right diagonal. So this equation, okay, our matrix is now 2, 3, 3, -1. Okay, 2, 3, -1. Now, okay, so right, so we're still on the Cramer's rule. The Cramer's rule. Okay, so the Cramer's rule. So we have our equation. So the matrix A is 2, 3, 3, -1. Okay, then we have our x and y that we're looking for. Okay, then we have our if it's AXC, our C is equals to the 8, 23. Okay, so what we do is for x to find the value of x, to calculate x, or what we'll do is we said x is equals to, if you look at the value, the matrix here, these are x values. So I'm going to replace this one with 823 for the x. So 823 for the x. So this will be 823, okay? And this is a free -1, okay? Then this divided by this matrix, the original matrix, which is 2, 3, 3, -1. Okay, when we simplify this, this one will give us -8 minus 69, and this -1 times 2, that will be -2 minus 9. So when we simplify it further, x now is equals to -77 minus 11. So this gives us 7 quickly. Okay, so how do you find a y? Why students prefer that one? So the y, you see, now I maintain 2 free, and I'll put this c value in place of 3 and -1 for y. So that y, so y will be equals to the determinant of 2, 3, 8, 23 all over 2, 3, 3, -1. Okay, so when we compute this, this will be the first one will be 46. Okay, and this minus 21 all over -2, -9. Okay, so our y is now equals to 22 divided by minus 11, giving us the value of y to be -2. Beautiful. So you see that the Cramers Rule is so quickly. You see, it's so quickly. So that's the reason why the students, I think, they prefer using the Cramers Rule, because all what we have to do is when we pick the matrix. Okay, so now let's see why they love it. So first of all, our matrix is 2, 3, 3, -1. Okay, now we're looking for values of x and y. So if this is our equation in mind of the matrix, okay, then we substitute the values of c. This is 823, so we'll put it here as we maintain free -1. So we ended up with this. Bear in mind that the denominator is the same matrix. This is 2, free, -1. It doesn't change. So the denominator doesn't change. Okay, so after computing the values, we had 7. Now, with the, look at it, with the y, we maintain 2 free, and they substitute the c value here. So you see, c value here. Okay, the same way, we multiply the right diagonal, which is 23 times 2. Okay, and we also will do the left diagonal, which is 3 times 8, which is 21. Then the denominator doesn't change. Okay, then that's what we got. So you realize that after using the Cramers law, it's, the first x value is 7, and our y value is -2. So as you compare, all the answers we got from the solving of all the methodologies or different type of methods like the elimination, substitution, mattress method, we ended up having the same value. But in terms of speed, if you know what you are doing, we realize that the Cramers Rule is the quickest and the fastest way of solving simultaneous equation in this form. This, as I told you earlier, this is an intermediate method. So we decided to apply 2 by 2 matrix or 2 by 2 simultaneous equation. But this Cramers rule also apply to 3 by 3 simultaneous equation. That is, if your simultaneous equation is involves x, y, z, okay, you can still use the same determinant methodology. That's the Cramers rule to be able to deduce the values that you are supposed to solve. Thank you very much for your time. I think this is a very long, discussion, but I think it's useful after going through this. When you go to an examination room when you have not been specified for particular question that you're supposed to use for simultaneous equation, if you know how to use Cramers rule, you can do it quickly so that you can buy yourself in a lot of time to be able to proceed to solve other questions. Now I'm so excited that you are here. Please go down and subscribe, please, and also like the videos so that will prompt us and then empower us to do more. Okay, and also if you have a question that you are interested for us to solve, you can put in a question down for us to be able to do that. Thank you once again. Bye.